In our next session, I'm going to make an introduction to the email security appliance. Okay, ESA can be defined as an advanced email filtering solution that is normally deployed in a network for two main purposes. One is going to be to provide protection against common email-based threats, such as, for example, spam, phishing, viruses, and other malware. So in this case, the ESA is going to be able to scan messages, is going to be able to detect potential threats, and you will be able to quarantine those emails or maybe simply drop them. Now, the second major purpose for using ESA is going to be able to fully control email communication. So similar to the web security appliance, in which case we are able to build policies to limit the number of websites people will be able to access, we can use the ESA to control email communication based on the sender, recipient, and also content of the message. Speaking of the actual functionality and engines available on the ESA, it is going to be first and foremost the ability to control email traffic in general, like set up some limits to police incoming emails, maybe build simple policies to specify who can send emails to us, in the same time discarding messages that don't match any of the existing mailbox in our domain. Plus, we will be able to build our policy to control the messages based on their content. For instance, we can set up the ESA to block messages containing a certain attachment or maybe certain content within the message, maybe header fields seen in an email, and many other elements. Advanced malware protection is also available for configuration. You can do data loss prevention, which is the ability of controlling outbound email traffic, looking for some sort of confidential information, like when you want to prevent your users from leaking out some data from your organization to the outside. It could be any type of personally identifiable information, maybe credit card numbers, or simply any type of internal document that you don't really want to leave your network. Authentication and encryption, this of course goes without saying. Authentication can be performed at least in a few different ways, where encryption is going to generally rely on TLS. The same as web security appliance, ESA can be deployed as a physical device. We have a series of physical appliances, 100, 300, and 600, where the 600 is generally meant for large enterprises. The 100 series is designed for small to medium offices. Now, as we will see, in case of both physical and virtual appliances, which platform you will want to use is going to be all about the performance, which in case of the ESA is expressed in the number of messages at an average size the unit can process per second or per hour. And as a general rule, it will all eventually depend on the number of security engines you have enabled on the ESA and also on the amount of security filters that you run. But of course, the more CPU cores you have or the faster the CPU is, the better performance will be. For virtual appliances, these you can run on the ESXi and Cisco UCS. It's pretty much the same stuff, the equivalents of the physical appliances, with the exception of this first OOV, a version of the image which is meant for evaluation or just testing purposes. But then 100, 300, and 600, these are essentially equivalents of the physical appliances. If we take a look at this in the documentation, I'm going to say ESA datasheet. And let's shoot for this second document, 2018. And somewhere down here, it will tell us about the differences between the individual physical, in this case, appliances, So of course it's also going to be the reg unit space, power consumption, and then the hard disk size, CPU, number of cores, possibly clocking, and of course amount of memory. So this is meant for small to medium offices. These two were the last, let's say, 3 of these are generally meant for large service providers or very large organizations. Now, speaking of the virtual appliances, as I said, these will run on VMware ESXi, these 3 hypervisors, and also on Cisco UCS. So this is for evaluation, and then these 3 are equivalents of the physical series. It's all about the memory you'll have to allocate, and of course the number of cores from 1 to 8. Depending on the platform type, ESA offers 2 or more physical interfaces labeled as data ports. But what is going to be different here from the WSA is that those interfaces can be used for data management or both. So it's not like on the WSA, where as we saw P1, P2, T1, T2 interfaces, they were generally meant for data, where management port could be used only for administration or for administration and the data plane. In case of the ESA, all interfaces, including this optional management port labeled as M1, whether you have it or not is going to depend on the platform. All of them can be used for data, for management, or for both types of traffic. And it's actually a pretty common design, especially for small networks, when you deploy the ESA using just one interface. Like for example, M1. In this interface, we will use it to handle email messages, incoming and outgoing, and we will also use it for management. It is generally recommended to place the ESA as close to the firewall as possible. Specifically, you will put the appliance, you will connect it to the DMZ port of your firewall, and this is going to be ideally the Ethernet edge portion of the network, protecting the unit from unwanted communication. So you will also have to think about firewall reconfiguration whenever you want to use it to protect this unit. And at minimum, what you will have to allow is going to be, I'm going to say that this is ASA. This is going to be our ESA, which is connected to the DMZ. And you also have the inside and outside. Inside is going to contain a, let's say, single SMTP server, like our Exchange. And this is going to be the internet. Okay, so if you wanted to deploy ESA like that, what you would have to allow on the firewall would be the communication on the DMZ for SMTP, I would say, from the ESA to anyone. It's not only going to be traffic that is sent to the internal SMTP server, but you also have to think about outgoing emails sent to destinations connected to the internet. So this is why the destination is going to be set to any. The source can be restricted to the ESA. You would also want to allow all DNS communication and HTTPS for services such as reputation. So I would also allow all destinations from the ESA. Of course, ESA would be acting as a source in this case. We're on the outside to DMZ communication. You would want to allow all SMTP from anyone to the ESA, like that. So this would be a minimum config you would have to put on the firewall to accommodate a design like that. And this is needed no matter if you plan to use just one interface, like M1 in this case for all incoming, outgoing messages and administration. Or maybe when you plan to, let's say, deploy another interface like the data port and connect it directly to the inside network, so it can talk to the SMTP server bypassing the firewall, which is known as a two-leg design. In both those cases, communication from and to management interface would have to be allowed as I showed you. Plus, if you plan to use some additional services like maybe syslog, or maybe you want to integrate the ESA with internal Active Directory, you would also have to account for that.